Hi, this is Eva for Once Upon a Timeline, and today I will complete my series on the Mandela affected brain. So there's been a lot of changes in the brain, a lot. It looks fairly normal on the outside upper regions, but down in the middle here, I don't recognize many of these structures. Now, about half of the names sound familiar, but they were a different shape for me, usually much more simplified. And then another half of these structures, I've never even heard of these before. I suspect that this has been going on and morphing for quite some time. I don't know when it exactly started, but a couple years ago, I first saw a cross section with these weird center parts here. So I think some major changes probably happened several years ago. But let's go through some of them. One thing I noticed on this particular image right away is this pituitary gland depicted like this. It looks like two balls, and I don't remember it like that. Here's an image of what it looks like now. It was not like that before. It used to just be kind of a little tiny gland. Now they say it's still the size of a pea, so it hasn't actually grown, but it looks like the shape has changed a little bit. Okay, that's not a huge thing. But also here, the thalamus used to be kind of a small thing. So I'm surprised to see it taking up all of this territory here. Now, if you look at what the thalamus does, it has several functions such as relaying of sensory signals, including motor signals, to the cerebral cortex and the regulation of consciousness, sleep, and alertness. So that's an interesting one. A lot of us have noticed changes in our motor skills and that they've improved, and we have a much larger thalamus now. So I think that that probably is related. Also, we've also noticed a lot of sleep disturbances. So there may be some issues with sorting out the new brain structure, perhaps. Hard to say, but this is interesting. Okay, so now here's one. This is a huge one for me. We used to have one amygdala, and in a lot of places it'll still refer to the amygdala. There's a lot of residual about the amygdala. A few places, though, are calling it the amygdalae, as there are two of them now. This used to be one small area near the brainstem. In fact, all of these structures that I remember from the past were just little tiny things on the brainstem down here. But they are much more specialized and in many cases larger now. This whole spiral thing in the center here is all new to me, and it's a trip. It's very much a trip to watch that. Also down here, the Raphi, I don't know how to pronounce that since it's new, but Raphi nuclei. I've not seen that before. So Raphi nuclei, their main function is to release serotonin to the rest of the brain. Now, in the past, a lot of these things were released just kind of, they didn't have their own place that they were released. It just was like, oh, brain cells release serotonin. So there's what we're starting to see now is specialized regions, especially for this, which we did not used to have. There weren't delineated areas like this before. Serotonin is the neurotransmitter that is basically responsible for, like, it's kind of a feel-good type of hormone. So it gives you kind of that natural high feeling. So that's interesting that we have specific regions for that now. Also, in recent years, we've been hearing a lot about serotonin production in the gut, which is actually rather new the last 5-6 years. They never used to say that before. At the time, before I knew of the ME, I just assumed that it was a new discovery, but you say a large percentage of serotonin is released from the gut. So I suspect now that that is also an ME. All right, so also let's talk about the amygdala. What do those do? Role in processing of memory, decision-making, and emotional responses. So we have, again, some issues of memory here and emotional issues. I'm wondering if maybe as some of these structures change, we get on a little bit of a roller coaster ride sometimes. I know some of us have said that we feel a little emotional sometimes during some of the shifts. This could be why. Okay, now another huge change is this putamen. I don't remember that at all, and it is large in here, very large. Now this one's an interesting one. Primary function of the putamen is to regulate movements at various stages, example, preparation and execution, and influence various types of learning. Okay, so Putamen is responsible for regulation of movements. A lot of us have said that we feel that our reflexes are a lot faster now, and that we're just kind of more amazing in that department. And the fact that this Putamen thing is developed and is very large in the brain may be part of that. All right, now my favorite one here, the corpus callosum. That one's a very interesting story. It's huge in here now. Now, when I studied the brain in college, there was no corpus callosum, and it's actually integral to brain function now. But in those days, we never learned of it, which is just shocking. Of course, we never, this cingulate gyrus here, I didn't learn of that either, which is, it's impossible not to have learned of that, because it's just such a huge part of the current brain system. But I covered that in a previous video. So corpus callosum. Corpus callosum is responsible for attaching the two hemispheres of the brain. Now, when I first heard of corpus callosum, I was already out of college, and they showed it somewhat like this. This brain looks more like I remember it all. There should be more curlicues in here. It's gotten a lot smoother. You can see this image. Look at how smooth that is. It used to be really more broccoli-like than it is now. Now it's smoothing out more and more. They used to say that there was a theory that the more curlicues you had in here, the smarter you might be, because it made more surface area for the neurons. But that storyline is gone now. Anyway, so when I first heard of corpus callosum, they said it was just a few fibers that spanned across the hemispheres. And so they showed images of it. You could barely even see it in an MRI. It was just a few fibers. It was just very nebulous there. And they said, oh, this helps and aids in communication across the hemispheres. So now, if you see it now, it's, instead of being between the hemispheres, it's actually mostly under the hemispheres, and it's very, very delineated band now. It's very sophisticated compared to it used to be. I suspect this has been growing for quite some time. I just, I never went back to look at the brain, and it never occurred to me that it was changing, so I didn't think there was going to be any major new structures to learn. So I didn't keep my eye on this, but yeah, once I learned a little bit about it, I thought I knew. So I have to say, though, this has probably been developing for quite some time. Okay, and there's one other thing here. I've noticed that on the corpus callosum, this finger here has been growing. And even when I looked at the brain and I started my series a couple months ago, this finger here was not nearly as large. And at first I thought it was part of the corpus callosum growing, but it is called the fornix. And this is the most active area I see right now in the brain, at least in large visible growth structures, is this fornix. Okay, so what does the fornix do? If you look over here, it's very interesting. While its exact function and importance in the physiology of the brain is still not entirely clear, it has been demonstrated in humans that surgical transection, the cutting of the fornix, can cause memory loss. So this is interesting. They're saying they really don't know what it does exactly. And in my experience, when a new thing shows up, a lot of times they'll say they don't know that much about it. I think that will change in the next couple of years, and they'll say that they've known this since 1969 or something. But for now, keep an eye on it. This is what they do know, though, is very interesting. There is some debate over what type of memory is affected by this damage, the cutting of the fornix, but it has been found to most closely correlate with recall memory rather than recognition memory. So recall memory is like remembering little facts and details. Basically what most of the MEs are going to be recall memory. Recognition memory is just basically, oh, I've seen that before. That's I recognize that person. I've heard of that name. I've heard of that word. But recall memory is the little details and facts. So what's the name of the person? Where did they live? Those things. Basically, recall memory is most of the ME. And here we have a structure that's been growing recently. In my view, this is the thing that's been the most active growing in the brain currently. So they're saying this means that damage to the fornix can cause difficulty in recalling long-term information, such as details of past events. So we're seeing a lot of abnormalities in those kinds of memories right now. And at the same time, the structure of the brain that is currently correlated with those functions is growing rapidly. So I don't think that's a coincidence. Anyway, just massive changes in the center brain. I can't even sort out a lot of them, and they're ongoing. So it's like trying to keep up with something that keeps running ahead of you. But anyway, yes, massive changes in the brain. This is Eva signing off for Once Upon a Timeline.